What's going on, ladies and gentlemen? We're moving on with chapter 8. This lesson 8.6, solving right triangles, in a way is a review lesson. Okay, so we're technically taking everything that we have learned throughout chapter 8, all about right triangles and being able to solve for every single thing in a right triangle, being able to solve for all three side lengths and to solve for all three angles. Okay, so a quick warm up, do not label the side lengths as opposite adjacent. Oh my goodness, I'm so sorry. This is the same warm up in the 8.5 lesson. I meant to change this, but I didn't. So life goes on. Okay, objectives. I will be able to summarize all the different ways of solving for missing side lengths and angles in right triangles. So like I said, putting everything that we've put together, right, solving right triangles. These notes put all the things we have learned in this chapter into one set of notes. So in a way, like I said, it's a review lesson. It's consolidating everything that we've learned. Okay, solving for right triangles. If you're solving for side lengths, right, the two ways that we can solve for side lengths is Pythagorean theorem and trig ratios. So the way that you know which one to use, if you have two given side lengths, that means you're going to use Pythagorean theorem. A squared plus b squared equals c squared. That's from lesson 8.1. If you have one given side and one given angle, that is how you know you're going to use trig ratios, either sine, cosine, or tangent, and that's from lesson 8.3. So if you are ever solving for side lengths, you're either going to use Pythagorean theorem or trig ratios. Okay, if you're solving for missing angles, if you have two given angles, you're just going to use triangle sum theorem. Remember, all angles add up to 180 degrees, which is a review from chapter 5. If you have two given sides and only one given angle, because obviously you have the 90-degree angle, if you have two given sides and no other given angles besides the 90-degree angle, you're going to use inverse trig ratios, inverse sine, inverse cosine, or inverse tangent. That's a review from lesson 8.4. Okay, and now we just have two examples. Okay, so let's take a look. All right, in this first example, we are given the 90-degree angle and we're given this angle, which means we can easily find this angle by using the triangle sum theorem. Okay, so triangle sum theorem means all three angles have to add up to 180, which means that 39 plus 90 plus this missing angle B has to add up to give you 180. This is a very unconventional way that I'm writing it this way, right? Oh, sorry, that should be 90, not just 9. So we add those two together. 39 plus 90 gives you 129, right? Which means that we subtract 129 from 180, which means that angle B is going to be 51 degrees. That one's super easy to find. Okay, now we have to find the two side lengths. Okay, so that means if we're solving for x, we have one given angle and one given side. If you flip back through, right, if you have one given side and one given angle, that means we're going to use regular trig ratios. Okay, sorry, I'm going in the wrong direction. So that means we're going to use regular trig ratios to find out what the measure of angle x is. Okay, I'm going to, right, we used blue for the angle, now we'll use red to find angle x. Okay, this is your opposite side. This is your adjacent side. That means to find angle x, we're going to use tangent. So we set it up. Tangent of 39 is equal to opposite over adjacent, which is 6 over x. Remember, x is on bottom, so that means the pattern is we switch and divide, which becomes x is equal to 6 divided by tangent 39. Right, you plug that into your calculator. Remember, if you're using the Google calculator, make sure you're in the degree setting. I'm using my handheld calculator. You can't see it, but I'm typing in 6 divided by tangent 39, and that comes out to 7.4. So that means the side length of x is 7.4. Right, this little symbol means about, right? So x equals 7.4. Now, if I'm going to use a different color, let's go with orange this time to find the value of side length y. Once again, 6 is still your opposite, right? So it works both ways. This is still your given angle. 6 is still your opposite. Now y is your hypotenuse. So that means we have opposite and hypotenuse. So to solve for y, we're going to use sine because we have opposite and hypotenuse. So we set it up as sine 39 equals opposite over hypotenuse. Opposite is 6. Hypotenuse is y. So that means the variable is on bottom, so that means we flip and divide. In order to save space for this problem down here, I'm going to go this way. So that means we end up with y is equal to 6 divided by sine 39. And once again, type that into your calculator, right? I do 6 divided by sine 39, and that comes out to about 9.5. So that means y is 9.5. Okay, now we have all three side lengths solved and all three angles solved. Okay, now over here, we are moving on. Okay, let's go with this tan color. Let's go with x. X is a side length, right? We're solving for side lengths. If we go back, if we're solving for side lengths, I'm sorry for all the mess. But if you have two given side lengths, you use Pythagorean theorem to solve for the third side length. So that's what we're going to use. To solve for x, we're going to use Pythagorean theorem. I guess to go back, I should write down what we used. So to find x, we used tangent. To find y in orange, we used sine. To find angle B in blue, we did that triangles equal 180, right? That we just used that the degrees add up to 180. Now, if we use this turquoise color to solve for angle x, we're going to use Pythagorean theorem. Let's just shorten that to PT, right? 10 is your hypotenuse, 4 is your leg, x is your leg, which means if we use Pythagorean theorem, I'm going to go over here. Remember, it's leg squared plus leg squared equals hypotenuse squared. So 4 squared plus x squared equals 10 squared. 4 squared, or 4 times 4 is 16, plus x squared equals 10 squared, or 10 times 10 is 100, right? We subtract 16 from both sides, right? 100 minus 16 gives us 84. So that means x squared must be equal to 84. Remember, to get rid of squared, the opposite of squared is square root. So we take the square root of both sides and we end up with x is equal to the square root of 84, right? We know that square root of 84 is not a perfect square, right? So that means we do have to simplify it. Square root of 84. Okay, I know that 4 will go into 84. 4 goes into, which means it should be a different number as well. Divided by 16. No. 84 divided by 36. No. 84 divided by 49. No. Okay, then let's just break it down by 4. Okay, notice that is our answer, but if we want to break it down, I'm going to go over here in this corner, just trying to conserve as much space as possible. Square root of 84, we break it down as square root of 4. 4 goes into 8 twice. 4 goes into 4 just once. So we break it down as 4 square root of 21. So actually, this is the best we can break it down. So the square root of 4 is 2. We cannot break down square root of 21 anymore. So that is another way to write it, right? Instead of writing square root of 84 simplified, it's 2 times the square root of 21. Those are the same. That's how we find x. Okay, now if we're solving angle D and angle E, let's go with a green color for angle D. Notice if we go back and check, if we're solving, again, sorry for the mess, solving for missing angles, we have just 2 given sides and no other angles. That means we're going to use inverse trig for both of these. Okay, that means we're going to use inverse trig for both of these. So if we put our theta here in this green color now, oops, sorry, we put theta in the green color for angle D. That means we did solve for x, so we know what that is. However, it's going to be really annoying dealing with square roots. It's much easier to work with whole numbers. So that means if theta is here, 4 is going to be your opposite, 10 is going to be your hypotenuse, which means if we have opposite and hypotenuse, that means we're going to use inverse sine. So I'm going to write that over here. All right, so we set up our equation, sine theta equals opposite over hypotenuse, which is 4 over 10. And to solve here, it means we do inverse sine. Again, trying to just use as little space as possible. Theta is equal to inverse sine of 4 divided by 10. All right, so you plug that into your calculator. Remember, make sure you're in degrees setting. Inverse sine of 4 divided by 10. I'm typing that into my calculator, and we get about 23.57, which would round to about 23.6. Now, technically, I know two angles. I could go back and use just know that all angles add up to 180, and that would be the easiest way to find angle E. But in order, so that way we can get more practice, let's go with like a fuchsia color to solve for angle E. So now, notice, now that theta is over here, if we wanted to use sine, we would have x and 10. But remember, we don't really want to use x because it's a square root. So now 4 is not your opposite side anymore. 4 is now your adjacent side. 10 is still your hypotenuse side. So now we're going to use cosine because we have adjacent and hypotenuse. So we set it up as cosine of theta. Sorry, someone just came in. So we set it up as cosine of theta equals adjacent over hypotenuse. Adjacent is 4, hypotenuse is 10. So now we're going to use inverse cosine. So theta is, oh, sorry, I forgot to write that we're using inverse cosine over here. Anyways, theta is equal to inverse cosine of 4 over 10, right? And then we plug that in. I'm using my calculator. Inverse cosine 4 divided by 10 gives us 66.4, which, or 66.42, which just rounds to 66.4. And remember, you can double check and make sure because 23.6, 66 plus 4 plus that 90-degree angle has to add up to 180. We double check. I'm typing it into my calculator. 23.6 plus 66.4 plus the 90-degree angle, and it does in fact add up to 180. So that's another way for you to check to make sure that you have the correct answer. Ladies and gentlemen, I'm really sorry I seemed really scatterbrained in this lesson, but technically nothing new here, just a way to summarize and put everything that we've learned in Chapter 8 all in one place. So make sure you bring questions with you to class if you have them. Let me double check. Yep, that's the last slide. Have a great day. Go Mustangs.